In the first section of Module 2, we will look at symbols and sets of numbers. So let's start by looking at a few examples of sets of numbers you may see as you go through this course. The only definition I'm going to speak about on this page is that of real numbers. Real numbers are all numbers that correspond to points on a number line. Hopefully you are familiar with number lines. We'll talk about that in a few slides. All the other definitions on this page represent a subset of the real numbers. You may want to take a few minutes to copy this down or to print this slide. You will see these definitions show up from time to time while you're working certain homework problems, problems on tests. So it'd be nice that you know what integers mean, what numbers are represented by the word integers or whole numbers and so on. But that won't be necessary to work every problem. While dealing with numbers in the real number system, sometimes it's helpful to compare two numbers. And we compare those numbers with these different symbols you see on the page. You may want to pause the video and write down these definitions. I will quickly go through these. The first symbol is an equal sign. That means the two quantities on the left and right side are equal. They have the same value. If two quantities don't have the same value, we may put a slash through that equal sign. That's the not equal to symbol. It means the left side and right side are not equal. If the number on the left is smaller than the number on the right, we would say it is less than, and we would use this third symbol. If the number on the left was greater than, larger than the number on the right, we would use the fourth symbol, the greater than symbol. Now, sometimes we use the third and fourth symbol in conjunction with an equal sign. We sort of mash those together so that the number can meet one of two different criteria. If the number on the left is less than the number on the right, or if the number on the left is equal to the number on the right, we use the fifth symbol, less than or equal to. If the number on the left is larger than the number on the right, or if the number on the left is equal to the number on the right, we'll use the last symbol shown, which is greater than or equal to. It is very important that you know how to use each of these symbols and the definition that goes along with it. Sometimes to compare numbers, it's also helpful to have a number line. A number line is a line on which each point is associated with the number. Let's start at 0. 0 is always a good starting point. All numbers to the right of 0 are called positive numbers. All numbers to the left of 0 are called negative numbers. We will see number lines from time to time in this module, as well as modules in the future. Now, when we look at any two real numbers on a number line, let's just represent those with A and B. We would say A is less than B if A is to the left of B on the number line. So you may think of it like this. Let's say A is 2 and B is 5. We would say 2 is less than 5 because 2 shows up to the left of 5 on the number line. So let's use our knowledge of the symbols we just saw and the number line to determine whether each of these mathematical statements is true. So starting with A, we have 4 is less than 5, and that is a true statement. We go to B. 27 is the definition of this symbol. 27 is greater than or equal to 27. Well, we know that 27 isn't greater than 27, but 27 is equal to 27. So this is also a true statement. Third example, 0 is greater than 5. Well, if I look in my wallet and I have $0, and you look in your wallet and you have $5, I don't have a greater amount of money than you do. So this is a false statement. And the last example, 16 is less than or equal to 9. For the same reason C was not true, D is not true. 16 is not a larger value than 9. 16 is not equal to 9. So this is a false statement. Let's try to use the same definitions and symbols that we saw a few slides ago, equal to, greater than, less than, to translate each of these sentences into a mathematical statement. You want to find the phrase that matches a symbol and then replace that phrase with a symbol in a mathematical statement. So for part A, we have 13 is less than or equal to 19. We see the phrase we're looking for in the middle of the sentence, less than or equal to. That's represented by this symbol, less than or equal to. So we would write 13 is less than or equal to 19. That's how we translate that sentence into a mathematical statement. Let's do that with the last two examples on this page. 5, we write 5, is greater than, we use the symbol that represents greater than 2. And for the last sentence, 7 is not equal to, remember that's an equal sign with a slash through it, 7 is not equal to 8. For the next four examples, let's use the symbols less than, greater than, or equals between the pair of numbers to form true statements. So we start with A. We have 4.7 and we have 4.697. We can show this with a number line. There are many other ways to do it as well. And let's say we have a number line and we've zoomed in to look at the numbers between 4 and 5. On that number line, somewhere between 4 and 5, closer to 5, we would have the point 4.7. Now, somewhere very close to 4.7, but somewhere a little bit to its left would be 4.697. Not quite as far along the number line as 4.7. So using that definition we saw before, if a number is to the left of another number on a number line, then that number is less than. Likewise, if 4.7 is to the right, in this case it is, then 4.7 is greater than 4.697. Going to the next example, we have 32.61 and 32.61. We can observe very quickly that these are the same values on each side of the box. So these values are equal. They're exactly the same. For C, we have two negative numbers, and we'll use the number line to compare these numbers as well. We have -4 and -7. So let's draw another number line. Maybe we'll put a few more values. We'll put 0 to the far right so we can fit other values on the line. And going to the left, we start at -1, -2, -3, 4, 5, 6, 7. I'll try to fill in those numbers as best as possible. Just know that each of these marks represents 1. So we will put one dot at -4, put another dot at -7. And we see that -4 is to the right of -7. So -4 is actually greater than -7. Remember that when you were dealing with negative values, the larger number behind the negative sign, the further to the left that number will be. For the last example, we have two fractions, 1/4 and 2/3. Now, just by looking at this example, it may look like 2/3 is larger than 1/4, and maybe it is. But we really can't compare fractions until we have a common denominator. Remember, to find a common denominator, we are finding the least common multiple of those two numbers. And to do that, you would make a factor tree and go through those steps that were shown in Module 1. For time's sake, I'll let you know that the least common denominator when we have a 4 and a 3 is 12. That's the smallest multiple that 4 and 3 have in common. So if we change each of those fractions to an equivalent fraction with a denominator of 12, we would have 3/12 and 8/12. So if we compare 3/12 and 8/12, it's easy to see that 3 is less than 8. So 1/4 is less than 2/3. There are other ways to compare fractions without finding equivalent denominators. You may change each of these fractions into a decimal and then decide what the larger fraction is from there. Either way will work. Let's now try to rewrite inequalities so that the inequality symbol points in the opposite direction and the resulting statement has the same meaning as the given statement. So first we need to be able to correctly translate the statement we're given. Here we have 27 is greater than or equal to 16. So to rewrite the inequality or to reverse the statement, first we reverse the numbers. This is our first step. We want 16 and 27 to change places. And if 16 and 27 change places, our sign will flip around the opposite direction. So instead of being a symbol for greater than or equal to, we should write 16 is less than or equal to 27. Now this may seem sort of pointless now, but as you get toward the end of this module and later on in different modules, it may be very important for you to be able to reverse inequalities, especially when we have variables that are involved. Also, when dealing with number lines, sometimes it's important to know the distance of a particular number from 0, regardless of if that distance is to the left or to the right. We denote that distance by taking the absolute value of a number. So the absolute value is denoted by a number inside these vertical bars. And this is the distance between a number and 0 on the number line. And this value is always positive. So if we look at the absolute value of -4, we're looking at the distance between -4 and 0. And we can count the tallies. We have 1 mark, 2 marks, 3 marks, 4 units to the left. So the absolute value of -4 is 4, a positive value. The same is true for the absolute value of 5. We look at the number of units distance between 0 and 5. 1, 2, 3, 4, 5. So the absolute value of 5 is also a positive number. No matter what type of quantity you have in the absolute value bars, negative, positive, or 0, the value will be positive, except possibly in the case of 0. 0 is neither considered positive nor negative, so 0 would just be 0 if it were in the absolute value bars. Let's find the value of each of these numbers, and they're already shown on this page. And we can see that the absolute value of 9 just stayed a positive 9. The absolute value of -6 became a positive 6. Whenever we remove the absolute value bars, that number becomes positive. It doesn't matter if it's a positive, a negative. In the case of part C, a negative fraction becomes a positive fraction. And then as we spoke about before, the absolute value of 0 remains 0. It's neither positive nor negative. It's just 0. Let's try on A and B to insert one of the symbols shown, less than, greater than, or equal to, between the pairs of numbers to form true statements. Now you'll see the difference between these two examples and the 4 previous examples where we tried to do this. Here we have absolute values. Before we try to insert a symbol to make this statement true, we want to remove the absolute value bars. So to do that, the absolute value of -4, remember when we remove those bars, that becomes a positive value. So 4, we're comparing 4 to 0. And we can quickly see that 4 is greater than 0. So we would insert the greater than symbol. For part B, the absolute value of -5 would be a positive 5. The absolute value of -9 would be a positive 9. And 5 is to the left of 9 on a number line, so 5 is less than 9. The last example we're going to look at is a word problem, and we're going to find the appropriate information and then answer the question. So we want to use integers to represent values in the statement. Remember, integers, that's the set of numbers 1, 2, 3, 4, as well as 0, as well as the negative numbers, and it goes forever in both directions. So we want to use integers to represent values. The highest elevation in a country is Mount Snowy with an altitude of 14,000 902 feet. The lowest elevation in the country is Green Valley, with an altitude of 218 feet below sea level. Now this piece is important, sea level. Let's draw a picture to see what that means. Sea level, we say that's 0. Heights above sea level are positive. Heights below sea level are negative. So when it says Mount Snowy has an altitude of 14,902 feet, well, we know that mountains are above sea level. So that's going to be a positive 14,902. When we see that Green Valley has an altitude of 218 feet below sea level, well, that would be a negative value, negative 218. Let's use that information to answer the two questions shown. The integer that represents the altitude of Mount Snowy, we said is a positive value, and the magnitude is 14,902 feet. The integer that represents the altitude of Green Valley, it was below sea level, so it's a negative value, and its magnitude was 218 feet. Use this slideshow to answer the questions in Module 2, Homework 1, Homework. Ask questions if you have them.